All right, here we're solving reciprocal trig functions, right? What to do when you have one of those cosecants, secants, or cotangents in play. So first step is going to be isolate the trig function itself. If I have some kind of multiplier or additive, I want to make sure I get rid of that to the other side of the equation first. And then the only new step here really is to take the reciprocal of both sides. Cotangent is 1 over tangent. So if I were to rewrite this as 1 over cotangent, I could substitute a tangent theta in for that. And I can get away with that as long as I balance the equation and do it to the other side. 6 becomes 1/6. And now I'm back to my old game here. Inverse tangent both sides. To isolate the variable. And that answer happens to come out to be 9.5 degrees if I'm in degree mode. Now 9.5, right, that certainly falls within range, 0 and 360, but tangent and all other functions have matching mirrored quadrants. So you gotta make sure you go ahead and finish the question as always. 9.5 is just barely in the first quadrant where tangent is positive. I know tangent is also positive in the third quadrant. And so that's when I wanna go hunting, fishing for my secondary answer here. So make sure it's congruent, kind of referencing the same angle. I'll go to that 180 mark, which is the x-axis, and I'll go 9.5 further. Guaranteeing I make that same ratio, the same equivalent solution here. So my two answers would be 9.5 degrees and 189.5 degrees. Let's do another example, a little bit more complex. Let's say I got much more things happening to my variable. I got a times 2, I got a cosecant, I got a -1, and all those have to be undone in the right order. Reverse PEMDAS order. So I'm going to add the 1 to both sides. Adding 1 will make a -3. Divide the 2 away on both sides. Now I have isolated my trig function. Now I'm ready and primed for my second step. Take the reciprocal of both sides. Now the reciprocal function of cosecant is sine, right? Some people have some trouble with that. Cosecant and sine are reciprocals. So that will be equivalent to setting it equal to -2/3. From here I can just inverse sine both sides. Isolating my variable, and that happens to work out to be -41.8. So as I inverse sine, as I got my variable by itself, my answer was within range, the typical range of 0 to 360. So before I start looking for my second answer, I gotta fix my first one. Make sure I land in the exact same spot as this -41.8. So I'm gonna add a full revolution, full 360, and get 318.2. as my first answer. Now from there I can start looking for my other solutions. And for sine, 318's down here, sine is negative down there. I'm going to look for the other negative quadrant for sine. So I'm referencing a lot of tables, a lot of backstory here. I know sine is positive above the x-axis and negative below the x-axis because it's tracking the y ratio, y coordinates. And so if I'm first answer is coming out of the fourth quadrant, I want to go hunting out of the third quadrant in a similar mirrored symmetric way. I know that's going to be 180 degrees plus this reference angle, 41.8. And that's going to give me my second answer of 221.8 degrees. Two answers. The only time I'd ever get one answer in these cases is if they landed on one of these quadrantal angles. If they landed on the actual axis and it had no mirror counterpart. But I should most of the time expect two answers per any full revolution.